Hello everybody and welcome back to the channel. This is CCNA Day 22, and in this video what I'm going to do is to configure OSPF, but all the routers are going to be in a single area, and that single area of course is going to be area 0. When you configure with a single area, the area number is not going to be important, but later when you want to extend the number of areas, then you need to have an area 0. So the best thing to do is to configure the first area that you configure as area 0, which is going to be your backbone in the end. So let's just talk about some things that we need to get ready before doing the configuration. The first thing that we need to do is to have some information in hand, and of course you have just done this before. That's going to be your planning before doing any configuration. So the first thing that you need to do is to have a router ID. A router ID is going to be very much similar to let's say plate number for a car or something like that. It is in the format of an IP address, but it doesn't have to be an IP address. If you configure this, that's okay. If you do not configure this, then one of the IP addresses on your router is going to be selected as the router ID. And we're going to see this later, but when I say one of the IP addresses on your router is going to be the router ID, I mean that, let's say you have multiple loopback interfaces. The highest IP address of the loopback interfaces is going to be selected as router ID. And if you do not have any loopback interface, then the highest IP address of an interface is going to be your router ID. Now, what I mean by this is, if you want to be deterministic, if you want to know what your router ID is, and let's say after a restart of an OSPF process is not going to change, then you need to be deterministic. You need to type in the IP address format for a router ID. Doesn't really mean that you need to have that IP address on one of the interfaces on your router. Next thing is just select the interfaces that you want them to be participating in OSPF. So for that, we are going to use a wildcard mask. And wildcard mask, as I have spoken about, is in another video. That's going to select the range of the interfaces. All of them are going to fall into this range. Or you can be, again, very deterministic. Select the interfaces one by one. And also, there is a second way of configuring that's going to be an interface level configuration for OSPF. The other thing is process ID. Process ID, of course, is going to be configured when you start OSPF process. Now, process ID can be any number. It doesn't really have to be a specific number. So you can just configure this any number on your OSPF process. Now, and you should know that you can have multiple OSPF processes, and the number is going to be locally significant. What it means is, if you have process ID number 1 on router 1 and number 5 on router 2, that's not going to be a problem. None of them are going to send the process ID to another set. Later, of course, when you go to higher levels, you will know that a process ID is going to be effective in some specific things, but for now, process ID is not going to be super important for us to check. And area ID, like I said, area ID is going to be important when you want to make sure that two routers are going to be adjacent on some networks. You need to make sure that the area ID is the same. Otherwise, this is not going to be possible. Okay, the wildcard mask, of course, is going to be again important. Once again, we're going to check this. If you have 0, this means that this should match totally, and it cannot really be different. 255 means that I don't care, whatever value is there, I'm okay with that. So again, you can just think of this as a range. You can add it to the beginning IP address, and 0 is not going to add anything to that IP address, which means that we have only 1. 255, of course, is going to add a lot of IP addresses. This means that anything that we have in that offset is going to be selected. We can have some examples. For example, network 192.168.10.64 and 00015. This is going to be added to 64. This means that we can have anything from 65 to something like 79 or something like that, I believe. And also /28 subnet, which is what we have right now. The block size is going to be 16 and wildcard is going to be 15. What we have, all wildcards are going to be one smaller than block size. The other thing is, when we have interface matching, we can select the whole network. 10.0.0.0.0.0.255. This means that from 10.0.0.0 up to 10.0.0.255 is going to be added. Like I said again, you can add this value to the relevant target. You can select a single IP address with 0.0.0.0. If you add this to 10.0.0.1, it's going to just give you 10.0.0.1. You can have matching multiple subnets in a range, and all of them are going to work. What you need to do is to just make sure that the interface is going to fall into the range, and that's going to do the configuration for you. Okay, let's just go for the configuration on a real lab. What I have here is, you can see that multiple routers are in here. I'm just going to make sure that all of them are going to be in the same area. Let me just show this in something in an easy way. So I'm just going to add a circle in here, and this circle is going to be okay. So I'm just going to increase the size, move it, and make sure that all these are going to be in the same. So this is kind of schematically showing you that everything is in the same area. Let me just add another piece of text in here. I'm just going to say this is going to be area 0, which is going to be my badge box. I'm just going to move it in here. So my OSPF area is going to be area 0. All the routers are going to be in the same area. They are going to create adjacencies. I'm just going to capture one of these routers interfaces so that you can see the messages that come and go. Before doing this, first of all, I'm just going to run this command on one of the routers, show IP protocol, hit enter. We can see that I don't have any routing protocol configured on this. You can see that it says that non-stop forwarding is available in here. It says this is aware of that, and it says that routing protocol is just application. Nothing is in here configured. So let's just do the configuration. Before doing this, I'm just going to right click on here. I'm going to capture one of the interfaces. Let's say interface E00. And by capturing this, we can see the OSPF packets that come and go. We can just examine that. Like I said, there are some messages like this, but what I'm going to do is to type in OSPF up here, hit enter. This is going to filter everything out, and just OSPF messages are going to be here. Let's start from router 1, and then I'm just going to start the configuration. So the first thing that we needed to do is to go to configuration mode, and then from here I'm just going to type router OSPF. And of course, I can have any process number. Like I said, the number is not going to be important. Maybe 1 or maybe 1000, whatever that you want to have. If you have multiple processes, then they are going to have different numbers. So hit enter. So OSPF is enabled in here, but the first thing that I want to do is to have a router ID. Like I said, if you do not select a router ID manually, then one of them is going to be assigned to you. So if I say do show IP interface brief, you can see that I have a loopback interface. This is just one, so for sure this is going to be my router ID. But I can say my router ID is something other than this, something that doesn't even exist on my router. So what I'm going to do is to say router ID is going to be 1000, something like that. Hit enter. Okay, so you can see that 1000 doesn't exist on my router, but I just selected to have this. I might have multiple loopback interfaces later. I don't want this to change automatically. Next thing is going to be my network command. Like I said, I can select this using network command. I can go under the interface and select the interface directly. I'm just going to show you both of them. But for now, I'm just going to say networks. And I want to type this. And the first thing that I want to do is to be very, very deterministic. So I'm just going to select 0000 for all of this. This means that only one IP address is going to be selected. Let's say interface E00 is going to be selected. So I'm just going to select this one, and then I'm going to say 0000. And finally, I need to specify what area this interface resides in. So for now, like I said, all the interfaces are going to fall into area 0. So I'm just going to say area 0. Okay, this is very important. You can see that with this, I have selected only one interface, and that was very, very deterministic. Now we have an OSPF hello packet which is sent to the other side every 10 seconds, right? So let's just select this to see what we have inside this hello message. So you can see that this is the OSPF packet, which is wrapped in IP protocol and which is wrapped in Ethernet header on top of that. But I'm just going to open this OSPF packet inside this. You can see that there is an OSPF header which says this is version 2 of OSPF. By default, we have version 2 and version 3. Version 3 supports IPv6, version 2 only supports IPv4. This is a hello packet like this one, and you can see that there are some specific things that need to match with the other side. So the first thing is source OSPF router's IP or router ID. This should be, of course, unique. Area ID is 0000. I said area 0, but so why do we see this area like 0000? This is kind of a configuration which is similar to an IP address, and you should do this. But if you only go with area 0, then the last sector is going to be set as 0. If you say area 1, the last sector is going to be 1. But overall, you're going to see this as 0000. Okay, so what other things? You can see that authentication is null. This means that there is no username and password configured for this. No password, actually. And if I just open this OSPF hello packet, you can see that the network mask is 255.255.255.0. That is the network mask. What it means is that the IP address which I have configured on this interface has a mask of 255.255.255.0. Every 10 seconds I send a message to you. This should match with you. The other thing that we have is some router priority, which doesn't matter for now. And of course, we don't have any designated router. You can see that for now, we don't see anything in here. No DR, no BDR. Okay, so these are some of the important things that we have. And I'm just going to open this to see if there is nothing else. No, there is nothing is important for now. So this is the OSPF packet that we have, and all of them are being sent every 10 seconds. What is the source? 10131, the exact network that I have configured. And what is the destination? That's the multicast service, 224.0.0.5. Okay, great. Let's just do the rest of the configuration. What else I want to do is I want to add the other interfaces as well. So I'm just going to say network 10121 is going to be the other one. And also I'm just going to say loopback interface is going to be part of the configuration. So I'm just going to say network 1111.0.0.0.0 is going to be under area 0. I hit enter, so my network configuration is done. So most of the important things have been configured here. So if I say do show run, and I'm going to say section router OSPF, you can see that I have summarized them to the most possible. So I hit enter. You can see that this is my configuration. Is there any other way to do the configuration? Of course, you can do this on their interface. So what I'm going to do is to just remove this configuration. I'm going to say no router OSPF1, hit enter. So no OSPF configuration for now. I'm just going to start with router OSPF1. Let's say that I'm just going to be deterministic about router ID. I'm going to say router ID is going to be 1000. This time, instead of using network, I'm just going to do this under the interface. So I say interface E00. And I'm going to say IP OSPF 1 area 0. Hit enter. That's the command. And now you should see that OSPF packets are going to start being sent again. So I'm just going to clear everything. So yes, it just started. I don't really have to do anything with that. And the other thing that I'm going to do, interface E01, the same command. Interface loopback 0, the same command. Okay, so this is this is recommended, of course, best practice by Cisco. And you should do this. This is more deterministic for you. Okay, now we have done this. Let's just go for some more messages. We have seen OSPF hello packets, but I want to see some more packet types in here. So let's just go to router 2 and do the configuration of router 2. I'm just going to select this type of a configuration again. So let's go to router 2, the router OSPF, whatever number that you want to. I'm just going to say router ID is going to be super deterministic, so that's between 2000, hit enter, and then I'm just going to say interface E00, and of course I can say interface range E00 to 1, hit enter, and then I'm going to say IP OSPF1 area 0, hit enter. So now there should be some more packets in this interface, but I have not captured this. I have captured this one. So let's do this on router 3 as well to see the configuration. You can see that after some time, I have this void message that says this is an informational message with 5. That's adjacency change message. And the process ID is 1. Neighbor is now in full state. Let's do this on router 3. I'm going to do return configuration mode. Router OSPF 1. Router ID is going to be 3000. Hit enter. Interface range is going to be E00 up to 2. And then, did I do loopback interface in here? No, I didn't. Interface loopback 0. I'm just going to do this. Okay, here. Let's go back. So I'm going to say IP OSPF 1 area 0. So hit enter and see some extra types of packets that we have. You can see that now we see the first thing that we have after hello is going to be the database description, DVD messages, and then because router 3 did not have full information of the network, it just asked for some information. Okay, so after that we are going to have update. So the second, the database description is from the other router, of course. Then we have the update. The other router is going to request, and this is going to receive this update. And finally, we have the acknowledgement, which means that the last part, and this means that now we are in full state, right? So these are the packet types that we can see in here. If I just click on one of these, let's say for example the update, you can see that on the update we have the version, the information, and then ls update packets. If I just open this, you can see that one LSA is sent for now. That's LSA type 1, which is router LSA. And you can see some information about the router LSA in here. For example, what is the link state, what is the advertising router, and then what are the networks that are connected to that. I'm just going to close this. I don't really want to do any more packet capture. I just wanted to show you how this is going to happen. I'm just going to add loopback 0 to OSPF, and this is going to happen for all the other routers. Let's just do this on other routers. So if I just go to router 4, go to configuration, router OSPF 1, I'm going to say router ID is going to be 4000, and then interface range is going to be E00 to 3. Of course, 2 is not part of it, but let's just do this. IP OSPF 1 area 0. Interface loopback 0 is going to be part of that. So it says that OSPF is not going to do anything on Ethernet 02 because this is not configured. That's okay, no problem. You can see the loadings is happening. R5 is going to be next. So router OSPF 1, and then router ID is going to be 5000. Did I configure router ID on R4? Yeah, I did. So, and then the interface range is going to be E00 to 3. IP OSPF 1 area 0. Then interface loopback 0 is going to be the same configuration. And finally, we are going to be on router 6. And then I'm going to say router OSPF 1. And what I'm going to do is to make sure that the interface facing the internet or the service provider is not going to be configured with OSPF. Most likely we are going to configure BGP or let's say static route on here. Some service providers support OSPF, but that OSPF process should be different from the OSPF process that we configure inside our network. So I'm just going to say E00 is going to be part of OSPF. So I'm just going to say interface E00, IP OSPF 1, area 0, and then I'm just going to say interface loopback 0, the same thing. Now there are some problems with this approach that I have. Let's just do this. I'm just going to save the configuration on all of these routers. Okay, so what I'm going to do now is to check the routing table on every router. What I'm going to say on router 6, for example, I'm going to say show IP route, hit enter, and this is the configuration result. You can see that I have all the loopback interfaces of my network and also all the subnets that we have advertised into OSPF. Okay, so we have a static route in here. I'm just going to advertise it to every router in the network, and then I'm just going to show you something. Let's just go back to the slides first. What we did right now is we did the configuration. Now we want to make sure that some of the interfaces might be advertising to, let's say, the network, but they are not going to participate in OSPF processes. For that, we are going to configure passive interface. Let's just go back to here. In my configuration, I will not have any information of this network E03 inside my network, right? Let's see this. I'm just going to go to router 6 and I'm going to say, okay, let's just advertise this 0000 into my network so that everyone can reach to me and then to the internet. That's okay, right? So I do this. On router 6, I say configure terminal, go to router OSPF 1. If you remember from before, I'm just going to delete this again. Router OSPF 1. If you remember from before, there's a command which is called default information originate, and then hit enter. This is going to advertise 0000 to every other router if 0000 is in the routing table. For now, this is in the routing table. So if I just go to router 1 and say show IP route, previously I didn't have anything about that. Now if I repeat this command, you can see there is a 0000. And this is, of course, external route. We are going to learn about these external routes later. But what is important is here, we have this 0000. But we don't have anything about 192.168.100 network, which is this one. Which means that if I try to ping, let's say 8888, and I hit enter, this is successful. What is the IP address on router 6 for that? That is 192.168.100, 254, right? If I try to reach this, on router 1, if I just say ping this is possible, right? Why is this possible? Because there is a 0000 network in here, and it says that with this we can reach to router 6, and router 6 of course knows about this network, and that's going to be okay. But if it did not have this 0000, then this would be not possible. Now, there are some other things that we can talk about. Let's say that, for example, I don't want to have any adjacency between router 2 and 4. What can I do? In that case, I would say, okay, this is going to be in passive state. Why passive state? Because I might want to have information in my routing table, but I don't want router 2 and router 4 to form an adjacency. That's it. If you say passive interface for a specific interface, then that interface is going to be in the routing table, information of that interface, of course, but that interface cannot participate in router adjacency. Let's do this on router 2 E00. On router 2, if I go to configuration mode, say router OSPF 1, hit enter, and then I'm going to say passive interface E00. As soon as I do this, the adjacency between router 2 and router 4 is going to be torn down. You can see that this is now gone. But do I have information about this specific interface on the routing table? That is going to be 10.2.4.2, I believe. So if I just go to router 5, for example, and say show IP route 10.2.4.0, show IP route. So you can see that I have information from that in my routing table, although this is a passive interface. So passive interface means that the interface is not going to participate in OSPF. There is no hello packet sent on this specific interface. Network is advertised in OSPF, as you saw that, and this is very much useful when you are facing some LANs with no routers. That's an important thing, because you are not going to create any kind of adjacency on that specific router. Advertising the default route, we just did this using default information originate. The only specific requirement is that 0000 should be in the routing table. Otherwise, you should specify always in the end. And it says that send unknown traffic to me. Although we didn't have 192.168.100 or 8888 in router 1's routing table, we just knew that we should send everything to 0000's destination, the one that advertised this to us. Loopback interface and router ID. Loopbacks are always up, so because that's a virtual interface actually. So we use loopback ID as a router ID, but I selected to be deterministic. And also the order, as I spoke about that, highest IP address of the loopback interface is going to be selected for router ID if you do not specify that. And highest IP address of an active physical interface is going to be selected in case you don't have any loopback interface and in case you have not deterministically set it for that. Changing router ID after OSPF starts, you can just clear the IP OSPF process to make this happen, or you can restart the router itself, although restarting router doesn't happen in production networks so often. A router ID is going to be selected. So that is what we did in here. We just did some OSPF configuration. I just showed you how you can configure an interface using network to be part of OSPF, and also I showed you that there's another way that Cisco recommends to use the interface configuration for that. I advertised the default route, I showed you the router ID selection, and I hope this has been informative for you. As usual, please like and subscribe to the channel, share this video with your friends, hit that bell button so that you're going to be notified the moment that we upload these videos. See you in later videos.